So Michelle, I think a great place to start is kind of understanding a little bit. There's, I think, been a lot of strong opinions about alternative proteins. What are they? What do they mean? There's a lot of perceptions. We're going to get into kind of what those perceptions are, what drives them, and maybe where they could stand to have a few corrections. But you know, this is the kind of space. I mean, obviously, with what you're doing at Hyfé, there's a significant amount of personal motivation that goes into starting a company from scratch and pursuing something that nobody has done before. And I would love to understand kind of what was your insight and motivation that inspired you to get into alternative proteins, and where do you see it going?
Yeah, absolutely. Hi, everyone. My name is Michelle Ruiz, and I am the CEO and one of the co-founders of Hyfé, like Tina Fey. My background is in chemical engineering, so I actually started the first 10 years of my career in the oil and gas industry working with ExxonMobil. Spent the first couple of years working in manufacturing, working with a lot of food manufacturers, really looking at different efficiencies on the actual factory floor. And then got moved to an oil refinery on the outskirts of Chicago, so in the Joliet, Illinois area. And there I ran a wastewater treatment plant. And that was kind of like the big aha moment for me in my career, where I realized that the process of cleaning water generates a lot of organic waste. I mean, the process of cleaning water contributes 1.5% of global greenhouse gas emissions. That's half of aviation. Significant. And the second thing is, like, people just generally don't know, because once that water goes down the drain, it's gone and you don't think about it. But when I was a little bit obsessed with this problem, I realized that food manufacturing, like food processors, generate the third largest amount of wastewater in the world. And I want everybody to think about like a can of chickpeas. When you open up that can of chickpeas, that water that's inside, I mean, it's touching our food. It's perfectly food safe. It's full of sugars and proteins, but once that goes down the drain, that's considered wastewater. And that's, there's a lot more of that at the factory where it came from. And that for me was like, wait a minute, there is so much opportunity in taking these sugars and nutrients and plugging them back into the food system and using them to fuel this alternative protein space, which has so much promise from a decarbonization standpoint. Really anything that touches fermentation does, but the sugars that you use to run those processes are super expensive. And so that's kind of how like my oil and gas life came together with alternative proteins, really as an enabler.
So I think that's really interesting, because from a perspective standpoint, I think the narrative around alt proteins from a consumer standpoint, we immediately jump to packaged foods, either in the grocery store or at a restaurant, and you didn't come close to any of those things where we traditionally think about. And so when you're looking at things like feedstocks and in-use products for alternative proteins, where do you kind of see like the current perspective around whether it's an Impossible Whopper or whatever it is that is the sort of dominates the narrative? Or where do you think we're missing? What are the points that we're missing in the alternative protein space in that conversation?
Oh, this is going to be a hot take, because I think all of us in the alternative protein space are we're just passionate about the potential of alternative proteins, but sometimes forget that we can build our own bubble. And last year I ran a consumer study just to kind of like see how people associated the word alternative protein, or really just the concept of protein. And a lot of the consumers that I talked to that weren't in our bubble were like, protein, added nutrition. And they weren't really thinking about it as a replacement to a more carbon-intensive source of protein. And so where I think we might be missing the mark is in how we share the story, where I think from the builder's perspective, like, we care about making alternative proteins an enabler to decarbonizing the food system, but I think that the consumer doesn't necessarily think about that when they're making a choice. And I think when it comes to something like climate change and sustainability, it's a little bit too much of an emotional topic for a consumer to like quickly make a decision at the grocery store. And so I think that the way that we like talk about the story and market alternative protein should be about health. And that's really something that's top of mind for consumers today. I mean, like, think about it. Like, you go to a McDonald's and you get a chicken nugget. Do you really know what's inside that chicken nugget? I would much rather buy a chicken nugget if I know that there's just like a whole bunch of pea protein in there. I mean, it's probably mostly soy anyway, but you know what I mean.
And I think so. There was an interesting data point that I saw on allergen sensitivity that kind of implied that there's a lot of sources for proteins, but there are oftentimes allergies that are associated with those sources. And so, what are your thoughts on kind of like increasing availability of proteins from multiple sources as sort of a consortia approach?
Oh yeah. Okay. So there's allergens associated, for example, with soy, which is like the one that most people think about, and then even whey protein from like a dairy standpoint. And then that kind of leaves the third sweetheart of the industry, pea protein, out there, but I think we still have challenges with like texture and flavor. That leaves a perfect opportunity for mycelium-based protein, so the root network of mushrooms, which can have a very neutral flavor, for insect protein, which I'm sure Sean's gonna be very excited to talk about, which can also have an extremely neutral flavor. I mean, I've had baked goods with insect protein, and I didn't even think about it twice. But I just think great opportunity for protein that can be really neutral, have versatility from a functionality standpoint, and be grown on waste side streams from food manufacturing. So like literally no more infrastructure additions outside of like using what you already have.
The waste streams, I think, is an important point too, because this isn't necessarily let's rebuild an entirely new food chain all the way from production all the way through to consumption. What you're talking about is recycling what was cast away.
Exactly.
And so how do you kind of see that evolving?
Oh, okay. So I think earlier there was a conversation in the last panel about like how sustainable are sustainable companies, and I think this is where collaborations between corporations and startups need to start getting creative. And so if are there any like food manufacturers, like food processing ingredients companies in the audience? Like raise your hand if that's you. I saw one hand back there. These companies that we're talking to right now are looking to valorize literally every part of whatever grain or input that they're investing in. And I think that there could be really unique business models where everybody wins without having to waste anything.
And does it require the creation of entirely new foods, or are you also kind of looking at drop-in ingredients for kind of the existing recipes, if you will?
I think it depends on where in the value chain you want to plug in. Hyfé actually started making mycelium protein powder, and that would require the creation of a new food. And then we realized like there's a bigger issue in the fermentation alternative protein space, which is the cost of inputs. Like the cost of sugar right now is prohibitive for a lot of these alternative proteins to reach price parity, which is super important if you want wide-scale adoption. And so we ended up focusing on the enabling technology, so taking wasted nutrients, or what a food manufacturer would call wastewater, before it becomes wastewater, and turning that into feedstock for fermentation that's a lot lower cost. And so in this case, like that would be a drop-in replacement within the value chain that would be able to like support the industry, but not necessarily create like a whole new category of something.
So in effect, then what you're describing is something quite circular, where your customer and your input provider are actually the same person or same company, same entity.
Yeah, absolutely. And there's like, I think again, going back to like how sustainable is sustainable, like there needs to be a financial incentive for people to like work together. And for us, for example, like we're taking wastewater streams while they're still food safe. And we are removing the nutrients, like the good stuff, the sugars and proteins, we're removing them from the water, which saves the food manufacturer a ton of money. I mean, like treating wastewater at an industrial scale is like spending a fortune just cleaning waste. And then it returns the clean water back to manufacturers, which, especially for anybody who's like currently struggling or foreseeing a struggle with water scarcity, is another massive dollar sign of like savings on water sourcing. And then whatever's left, we actually take and turn into feedstock that then plugs back into their value chain. You know what I mean? And so there's like more of a financial incentive that I think drives a lot of these sustainability ideas.
Well, this has been really fascinating. I want to be mindful of time and give folks in the audience an opportunity to ask questions.
They're so like, she's talking about waste.
Well, what would you say, so from a product standpoint, what would you say is the closest thing, if we were to, I'll take this back to kind of that grocery store. So if we were to walk into a grocery store, what do you think would be a product we might be able to find that is an approximation of where you think things are, the best approximation of where you think things are going?
In terms of alternative proteins overall? Oh, I mean, you can literally go find this first company in the space already, Perfect Day. Perfect Day is a precision fermentation company that makes whey without the cow. They essentially engineer microbes like yeast to make whey protein. And then they use food science to turn that whey protein into ice cream. The brand is called Brave Robot. You can find it literally at any grocery store at a good price. They just released a milk brand called Bored Cow. They have a whole bunch of different things like cream cheese. That is one perfect example of a precision fermented alternative protein that both doesn't require the animal, but could also be connected, especially through a circular process, to a dairy manufacturer that has wastewater that wants to expand their portfolio and essentially secure resiliency as, the food system starts to change.
Interesting. Thank you for that. I think let's go ahead and bring up Michael and Sean. And while they're on their way up, I wanted to ask you one more question about this product that you mentioned, and are you aware of other folks that are already kind of integrating in with, and maybe I'm kind of stealing a little bit of Sean's thunder because I think his answer is actually, his company is actually the answer to this question. But in terms of companies that are already kind of plugging into existing production facilities to kind of do exactly what you're talking about.
Yeah, so there's Sean, and we'll let him talk about how insect proteins can plug into existing infrastructure, but I think another set of companies are those that are taking spent grains from like an Anheuser-Busch, for example, and turning it into like a high protein flour or really kind of those levels of upcycling.
So you kind of mentioned one of, I think when people think about fermentation, one of the names that they think about first in Anheuser-Busch, right? So, and I know I've talked to Beth about this a few times as well, that when people think about fermentation, beer is usually one of the first things that people think about. But before we get, just to kind of expand a little bit on what fermentation is, I think one of the things that's really interesting about this panel is the potential for collaboration across all three of the organizations that you guys are working with in pursuit of that sort of circular sort of relationship within a production facility to make something, take the cast away from the thing that was made, and then make something new. And so I think maybe what a good place to start with all three of you would be, well, actually, let's do introductions first. I'm getting ahead of myself. So Sean, maybe we'll start with you.
Perfect. Hello. My name is Sean Madison. I'm the Director of North American Business Development for Innovafeed. We are a French-based biotech startup that produces insect-based ingredients. So if you've never heard of insect-based ingredients before, they exist. They're out there. The reason why I don't have a French accent is we are expanding to the North American market in a big way. We recently broke ground on our facility in Decatur, Illinois, in partnership with ADM, and that will become the world's largest insect production plant. I'm a proud Illini grad, class of 2013, and my background has primarily been in the food space up to this point. I joke with people that I keep moving more and more upstream the value chain. I started in retail. I most recently was in consumer packaged goods, and now I'm basically in feed ingredients. So I'm not sure how much more upstream I can go, but we'll figure it out from there. And thank you for having me.
Thank you, Sean. Michael?
Sure. Thanks, Jack, and good morning. My name is Michael Tai, and I'm the co-founder and the CEO of Boston Bioprocess. And we are building a fermentation scale-up and development platform to help bioingredient companies to basically transform their technologies from lab and into a scalable process, and then eventually go to market. I guess as you can tell that from the name, we initially started the journey at Boston when I was still there, and because of there's tons of attractive incentives and the great sponsorship from the university, we actually moved to Champaign, Illinois, and start co-building our facility. So yeah, really glad to be here, and look forward to the discussion.
So I think what I'd love to get from each one of you is sort of how, just to kind of bring that conversation back around to precision fermentation and the role that it has in what you're doing and the role that you see it playing as the all-protein space kind of emerges. And Michael, I think we'll start with you and kind of work our way backwards toward closer to a packaged good, but maybe you could kind of speak a little bit to the challenges in precision fermentation and how your company kind of resolves those.
Sure. Yeah, so I guess, in a way, we're kind of playing sort of enabler or even a middleman kind of a role. And how we've seen the synbio or precision fermentation space that has been developing, particularly in the, if you want to break the development in the past 10 years and then in the past 5 years, is that there's tons of resources, including investment, that has been going into synbio space or precision fermentation space that has been enabled quite a few newer technologies or even newer generations of ingredients. For example, that like Michelle was saying, there was fungal protein fermentation, there was biomass type of fermentation, there was also ingredients fermentation. For example, companies like Impossible Foods or Motif that's producing heme bovine myoglobin from yeast platform, or some of them from fungal platform. And these molecules, in the past years, basically are all from sort of biopharma or biomedical world. And now we basically are able to using precision fermentation technology, industrial fermentation technology to get in there. So with all these booming up, let's say, of development, one particular issue here is if you look at where the resources are focused in this space, it's primarily on the upfront or upstream side of the development, where folks are having great knowledge on developing the strands, focusing on metabolic engineering, on re-engineering some of the host platforms to be able to produce or metabolize certain molecules. But then where the problems or the gap shows up is that once the lab side of the technology is relatively mature, let's say, then how do you exactly transform that into a commerciable or scalable process? So there's two questions there, right? One is yes or no. Are you able to really do it in a scalable way? And the second question is how much? Right, so are you really able to get this into an economical situation where it can be applicable in the current industrial practice? So what we do is basically to help in these two fronts, to help you answer yes or no question, and then help you answer how much question, and then we deliver a solution to help folks go to market, basically.
And Sean, I think to kind of pick up the conversation that Michelle and I were having on feedstocks and upcycling feedstocks and kind of that complementary relationship with an existing production facility, maybe you could share a little bit about how you see insects being a critical part of that sort of process.
Yeah, well, first of all, I think this kind of upcycling is almost a prerequisite for alternative proteins. Sustainability is kind of at the core of the value proposition for alternative proteins, and upcycling is one of the best ways to do that. You're basically taking these available nutrients and you're turning them into high-value ingredients. And so what we do, we don't do precision fermentation, but the idea is similar. We take these existing feedstocks, and what we use is basically industrial byproducts. I actually hate the word byproducts. It's like I'm just going to call them products at this point. We take industrial products from the milling process, typically like a stillage and a bran, and we feed them to insect larvae, our black soldier fly or Hermetia lucens, and in the process of their life cycle, they can transition those nutrients into really high-value ingredients. So we say that we're solving both upstream and downstream problems. On the upstream, we're solving problems for our partners, those grain processors, with what to do with these outputs of their industrial processes. And then on the downstream end, we're solving problems for certain markets that are really looking for expansions of the ingredient basket to kind of find new proteins. Aquaculture is a great example. One of the fastest growing agricultural industries, but typically the main input in aquaculture feed is fish meal, and fish meal supplies are dwindling. It's horrible for the environment, so aquaculture is very, very open to exploring these ingredients. And I don't know if anyone fly fishes around here, but spoiler alert, fish eat insects in the wild. So it's a really good market for us. But same can be said for things like pet food, and then just if you've seen the cost of feed and how wild it's been over the last few years, I think everybody can agree we can explore more opportunities there.
And I think I think just in sort of disrupting the perception that ultra protein means a new kind of either meat replacement or something like that. I think you hit on something where I think for most of us, and it's not, I would say, super common, if at all, in the more sort of broader narrative around alternative proteins. Fish food is not the first thing that comes to mind when we think about an alternative protein. So I think it's valuable augmenting the end uses, Michelle, that you were mentioning before. This is not something that is just replacing the meat aisle at a grocery store. This is augmenting that, yes, but it's also in the dairy aisle, and it's also in the frozen seafood section, or fresh seafood section, I suppose, as well. So I think one thing that I would love to get from all of you, Michelle, maybe we'll come back to you for this, is sort of like, as you kind of see this evolving, what are some of the end uses that are perhaps not top of mind for people that you think that people should be aware of?
For alt proteins?
Yeah.
Okay, I think when you talk about alternative proteins, you think immediately like a meat replacement, for example, but there are some really curious functional proteins and amino acids that can be precursors to different types of industrial chemicals as well. And so I would say that that's probably one area just below the surface of what a protein actually means. It's not always meant to be edible.
So can you expand on that a little bit? Because I remember that came up in another conversation we had a little bit earlier, and it was kind of a fascinating, again, when we think about proteins, it's sort of this very, very narrow view, but it's much, much broader than that.
You know what, like for when we pass it over to Michael, maybe he could talk about his experience at ADM making some of those like specific molecules, but one thing that I think is cool to share is going back to my mycelium side, so the root network of mushrooms, which is really interesting. You can turn what is really a protein and fiber food into materials that are very curious. So for example, with mycelium, if you grow a block of mycelium, it's really good at insulating, like pretty competitive with styrofoam-based insulation. It doesn't burn, it floats. And then also in terms of like stress fractures, it has microfracture failure mechanisms, which for building and construction is like huge, right? Instead of catastrophic failure. And so like, yeah, not all proteins can be food, but like we can take advantage of like the structural properties of proteins and fibers that would be used in the food industry to make some other really unique things.
So, Michael, maybe you can kind of pick up there in terms of precision fermentation and the role that it has in refining proteins into non-food use and maybe some of your experience there.
Sure. Yeah, I guess maybe a good point to start kind of thinking about the transition and how sort of precision fermentation is contributing more is probably maybe like looking back, if you kind of thinking about how fermentation has been developing and what types of molecules it's producing, right? Is kind of a couple of good examples to sort of like mark what a fermentation era it sits in is, the first one is basically soy sauce, let's say. That's been produced through fermentation for like, 100 years or so. Of course, there's not much technology in here, right? You just basically soak it and then it's a solid state fermentation. And then maybe another one is basically lysine. So if you think about even like Michelle was saying that, ADM produces, 500 million pounds of lysine every year, and a majority of them go into, the animal feed. So that's kind of maybe another molecular that can be sort of a markable sort of a molecular to represent fermentation technology in the industry space. And now where we are in is we are basically able to use precision fermentation technology to produce quite a few tons of categories, I would say, that basically can be alternative solutions for chemical industry and for agriculture industry, right? Animal feeds is a good example, like lysine, serine type of technology. And then for chemical industry, there's, bioplastics, PHA, PHB, and then there's nutritional products, DHA, ARA type of products from algae. And then there's, goes into the food, right? There's yeast proteins, intracellular proteins as well. And there's alternative milk, lactoferrin, alternative cheese, which is casein. So I think that's kind of, I guess, how I see it on development and what fermentation can keep contributing to. So I think the space is quite big.
And Sean, as the sort of industrial process kind of bolts on these additional facilities and capabilities, where do you kind of see that, how do you kind of see that evolving in terms of the kinds of facilities and the kinds of companies that they partner with?
Yeah, it's a great question, and honestly, we chase our feedstock. That is what determines our industrial deployments. We are, just to give you a sense of the scale, we're making tens of thousands of tons of insect protein per year. We also make oils, and our insect poop is what we call frass. It's kind of a fancy term for our fertilizer product. Not sure where that name came from, but that's what the insect space has determined we're going to call that. And yeah, so when we make that kind of scale, you need hundreds of thousands of tons of feedstock. And insects are a really classic case of you are what you eat. If you get consistent high quality feedstock, you'll get consistent high quality end ingredients. So we look for really large partners that have this high availability of that kind of feedstock that we're looking for. A lot of grain processors. We're building with ADM in Decatur, the world's largest corn processing plant there. We work with a wheat processor in France called Terrios, but we're exploring a lot of different avenues, including ethanol production, for example, that processes a lot of grains as well. And I think one of the, right now we own kind of all of our technology. We have built this entirely ourselves, and we have a lot of IP, and we're very proud of that. But in order to really scale the way we want to, maybe down the line 10 to 15 years from now, it's something that we could potentially license out to partners and really kind of, turbo boost that kind of industrial deployment to make insect proteins and oils and our frass kind of more available in the markets that we're working on.
And if you kind of project forward in terms of when we think about insects as livestock, which is probably would have been kind of a funny thing to think about, but I mean, we can't call it a crop. I mean, I think it's more appropriate to think of them as livestock. You think of insects as a new source of a base platform to kind of build off of, whether that's fish food or whatever else. Kind of like, what do you kind of see on the horizon of what could potentially come from harnessing insects as a resource?
It's a good question. Yeah, and insects kind of do exist in this gray area. In some capacities, they're treated as livestock, and some they're kind of treated as this other. So that's always an interesting thing to navigate. But I think we want to explore as many avenues to valorize our ingredients as we can. Typically, we've talked about the feed markets, which is kind of where I spend the lion's share of my time. But we are looking in direct human consumption as well. We are looking in non-feed applications, whether that's like biofuels or oleochemical applications for our oils. And I mean, honestly, the opportunities are endless. I think one of the things about alternative proteins and alternative ingredients in general is when you boil them down, the nutrient profile is what speaks for it. And where are those, it doesn't matter if it comes from insects or mycelium or what are these amino acids being used for? What are these fatty acids being used for? And so that we kind of use that as our guidepost to explore different opportunities.
And Michelle, you kind of hit on that a little bit earlier, so maybe it'd be good to kind of hear you expand when you talk about repositioning the narrative to the consumer and refocusing that on the nutritional profile. Maybe you could expand a little bit on sort of that unique, what proteins bring to the table in terms of a unique nutritional profile.
Yeah, so alternative proteins, many of them bring a complete protein, so digestible, fully accessible nutrition. But then they also bring benefits to the table like no cholesterol. I think the industry is still trying to transition from like what oil sources they're using, and that's just part of like an early industry growing up. But so far as we can solve for some of those ingredients that we're using that essentially try to target flavor first, so you don't kill your company before you actually get to grow and optimize it, then like we're good to go on like a full nutritional revamp of how we eat. I also think that it's not just about like how do you replace an animal, it's also how do you meat shouldn't be the enemy, right? Because then you're having people make a moral decision or an ethical decision, and that's too difficult when you're at the store. But I think it's also about like how do you give more versatility, more excitement with food to everyone in the world, so that I don't have to eat chicken every single day and get bored of it, but I can eat chicken one day, a insect patty the next day, some tofu the following day, and like just make my life a little bit more exciting from a food standpoint.
I think one of the things that I always kind of like to point out on that topic specifically is that 30 years ago, the idea of taking a slab of raw fish and sticking it on a chunk of rice was probably not very appetizing for a lot of people, but it's a premium food now. We see it that way. And my kids have eaten an insect burger, actually. We had some insect protein from a startup that came through the Illinois AgTech Accelerator, and I ate it on camera, and it was good, and my kids have been pestering me, when are we going to have another grasshopper burger again? And so it's something where for them, they're excited by it, they're curious about it. They weren't gross. My wife was a little bit more reticent about it, but the kids were excited about it.
We'll get her there, don't worry.
But you know, like, for me, for example, I eat lunch in my office every single day during the work week, and I personally, as a consumer, don't like the taste of reheated meat because it tastes kind of odd. And when you microwave it, like just nuke it. And so I generally use alternative protein options that reheat better in a microwave. And then over the weekend, I go eat some steak because it's my weekend and I'm like relaxing. And I think having options helps.
Yeah, so we have about 10 or 15 minutes left, I think. So we do have some questions. All right, great. Go for it.
So the first question is, what hardware innovation is needed to support alternative protein development and manufacturing? I wish someone could provide me X. And I'm looking at Michael because I know he's working in that space.
Yeah, that's actually a very interesting question. So certainly there needs to be some advancement on on hardware side, because I guess there's a name of precision fermentation for a reason, right? You need a sort of a better, tighter, and maybe more precise control. For example, when you do feeding controls of your carbon, of your nitrogen sources that are feeding into the bug while you're fermenting them, that you need a little bit of sort of a, in general terms, better side of the control of them. So that needs some advancement that comes from the hardware side. But what's kind of making this question interesting, though, is that in a lot of times that when you are developing and transitioning into new technology-based ingredients, you come into some sort of a dilemma, well, that if you have too far advancement on the hardware side, your COGS, which is your cost of goods, usually would go up together with it. So where that dilemma comes from is that in a way, when your technology is so new or so fancy, you actually would want to put them into the ground, well, that most of the existing industry pieces could run with your technology. Because otherwise, that your cost of goods will be significantly high than the existing industry, right? So think about, let's take alternative protein as an example. If you're trying to compare with, let's say, casein from traditional milk industry, and you say, I need a significant advancement or fancy side of the equipment to run the fermentation to produce casein, your COGS would very likely be, let's say, way over $100 per pound, or a couple $100 per kg. And while at the same time that milk casein is only $10 per kg, right? So we do not want that situation to happen. So the role that we want to play is we wanted to steadily in sort of advancing the hardware side of the things to make the infrastructure side of things more enabling for this industry, and particularly for precision fermentation. But we also want to be careful on not developing technologies that can only run on so high-level advanced equipment. Otherwise, you're going to end up in a situation you will not be economically compatible to the existing sort of traditional way of producing certain moleculars. That would be my answer, and hopefully this helps.
So I kind of want to piggyback on that, actually, because I think one of the things when we look at supporting the initiatives that all of you are working on, there's sort of that component of the technology that you're developing in-house, but also that you're leveraging outside of your company. And so as you kind of look at innovations and partnerships that are currently helpful, but also, additional, players in the ecosystem that maybe don't exist or that are still in emerging, where do you kind of see that as having an impact on the development of alternative proteins?
I think some of the earlier alternative protein companies in the fermentation space were fully vertically integrated. Like there wasn't a lot of capital equipment that they could access, and so they had to build their own. There wasn't a lot of talent, so they had to train their own. And now that the industry has progressed, especially with a colder investment market, people really, really have to look at diversifying where they get those resources from. And so, for example, when we were making mycelium protein, Michael helped us make that, and IBRL gave us the tanks and a lot of the know-how on how to scale that. And so being able to like work within the ecosystem to stay capital light and stay OpEx light, I think is huge.
Sure, yeah, I'll add a little bit to it. I would say that kind of the developing trend, though, I would say, is I think in our eyes, it's in some ways it's very similar to the development of oil industry, maybe even in 1980s or even earlier, right? Well, when a certain new space is, let's say, booming up in an early stage, you see a lot of vertical integration just because the space is very small and there's very fewer players in the space. So if you look at the sort of, well, nowadays the giant companies, right, that they basically own everything from, let's say, synthesizing catalysts and producing them all the way to running, the enzyme catalysis and then synthesis of reactors and all the way to maybe even product distribution and redistribution. So that's what vertical integration kind of plays a critical role at the beginning stage of a certain space. But now I think that SynBio has gotten into a stage where that there was the speed of upstream technology has booming up so much in a way that it enables the relative downstream side of the things be more sort of segregated, I guess, in a positive way, right? Because at the end of the day, I think for most of the players in the existing space, you have to contribute sort of where your strongest suit is at. Because otherwise, if you keep getting bigger and bigger, you will lose the relatively not so competitive side of your business, which I think to us it's certainly a good thing because we do want to see the landscape divides into a situation where folks who are good at metabolic engineering will develop the strengths, and then folks who are good at developing the processes, for example, RBL is a great example, very well running business to help in this space. So that's their strongest suit, and then there's the downstream folks who focus on, let's say, how do we turn precision fermentation supply chain into more or less of a normal or traditional supply chain? Because at the end of the day, you do have to get in there. Otherwise, you won't be able to be competitive, right? So I think that's how we see the space develops into, and we hope that sort of less vertical integration and more segregated contribution could help this space advance more.
So we do have another question, so why don't you go ahead? Give it just a second.
How about now? Okay, good. Yeah, so I've been involved in the biopharmaceutical space ever since the industry started more than 30 years ago, and so I've been part of and watched that whole industry development, which is very dependent upon protein production from fermentation. And as part of those products, it's always been, that's still today. We're coming up with alternatives, but that's still very important. But biopharmaceuticals is a drop in the bucket compared to food production, and capacity has always been an issue throughout the whole biopharmaceutical industry from the very beginning. And technology has helped to make a lot of progress in terms of being able to meet that capacity, but we still today outstrip the need by what we can produce. And so production capacity is key. Food production, biopharmaceuticals is a drop in the bucket compared to what food for either animals or for humans or whatever is involved. How do you see that you will be able to meet that need of capacity? Because, even though I think great discussion just now about engineering and advancements that are occurring, but still to address that issue of capacity is going to be absolutely key in order to move forward with being able to meet the needs for food.
Capacity in terms of steel is a major bottleneck in the industry, and capacity in terms of feedstock is also on the horizon. you take a look at, well, from a steel standpoint, you have the Michaels of the world, and the IBRLs of the world helping debottleneck capacity. It still doesn't solve the problem of industrial scale capacity. That is still a problem. I would say on that end, if you have taken a look at Biden's like scientific boards, like biomanufacturing report, there's going to be a lot of funding coming through to make biomanufacturing hubs. But I still think that that's where the U.S. hasn't been moving as fast as foreign investment. And so one way in which we're starting to see more interest in competitiveness from a U.S. standpoint. But then the other side is feedstock. And if we look at the U.S., we're the largest producer of corn in the world. Corn is, the mainstay feedstock, corn, sugarcane, and sugar beet for fermented processes, including pharma. And just the ethanol industry uses 45% of all of that crop. And so what we're looking at is not just like a steel constraint, but also like how on earth are we going to power this biomanufacturing future, which is absolutely necessary if you want to decarbonize the world.
Yeah, and thank you. That's really a great question. I think I want to start answering with a very positive note here that the fact that capacity even becoming a question for precision fermentation is a really, really good sign on how far technology has advanced, right? So if you think about sort of every single capacity or every single steel on the ground for every industry, it would only come to a critical point when there's tons of upfront technologies trying to squeeze into this space and asking demand for production, if you think about it, right? So if all these technologies are, let's say, crappy or broken, then nobody would care for what capacity I would get. So I think that would be my positive note on how far this space has been advancing, and we're very happy to see that part. And a couple kind of perspectives I wanted to share on how we try to solve this issue. One is, I do think major big players, way bigger players than where we are, companies like Cargill, Bunge, and ADM, we've always been kind of actively or proactively thinking about how do we turn sort of first generation asset into a second generation. So for example, questions like, can I run alternative protein on ethanol fermentation? I mean, most of you guys know that it's a no to that question. But there's some retrofit or modifications we could do, right? And then there's questions about, can we turn some of, let's say, a single amino acids fermentation asset into precision fermentation asset? And well, there's couple questions there. One is capability, the other is market demand, because you don't want to drop the single amino acids demand like right away. So I think all these are in sort of the first category of transition, which is how do we make things better based on, let's say, first generation of assets or even fully depreciated asset in the past 20 years, right? So that's one. And I guess this also kind of correlating to how you want to develop your technology at the beginning point, right? So in a way, let's say, I could have a fancier technology, but I can make it work with first generation asset. I would call that a sort of awesome solution now. But a lot of times you basically can't, right? You need a tighter and precise control for fermentation, for feeding and other things. So then that's the kind of getting into the second category, where companies like Liberation Labs, Synonyms, they're basically raising significant capitals, from Wall Street, from large investors to be able to build significant capacity. And then there's the Biden executive order to sponsor biomanufacturing hub. And I think, Illinois has a great opportunity, with RBL being here, with ADM being here. There's a significant regional advantages on sort of securing funding and building significantly larger scale asset. That would be my kind of two perspectives to show how we sort of solve this bottleneck. But generally really happy with this question that, this even become a question, I would say.
Can we squeeze one more question in? All right, great.
Yeah, I would like to add another perspective to the biopharmaceutical topic it brought up. I know this session is about food and nutrition, using alternative proteins for food and nutrition. But what about using alternative proteins created by plants to bring better health care to the society? Such as using plants to produce immunogens, for an example. Immunogens are proteins, alternative proteins, which creates immunity in our body against globally problematic infections such as respiratory diseases. At Fruit Vaccine Incorporated, the research park company, I have spoken with you, Jack, we develop most natural way possible vaccines using immunogens created by plants, natural plants. And that's the most painless, pain-free, patient-friendly, environmentally friendly way to create and most easily scalable way to create vaccines against globally problematic diseases like triple-demic we are experiencing right now. Our NSF-funded project, with our NSF-funded project, we are creating such a vaccine against RSV, one of the triple-demic diseases, together with COVID and flu. So I like to talk with you if you are interested. I hope there will be sessions like that coming up using plants against the infections such as respiratory diseases to create vaccines and immunogens.
I think it's a novel concept, and I'm also seeing that happen actually in alternative proteins and across different sectors where people are pretty much using what we have, again, in the most efficient way.
Yeah, totally. And congratulations on securing the NSF funding. I mean, molecular farming is a great, another booming up technologies, right? And well, most of the folks are pretty familiar with corn, I'm assuming, but then, I mean, I can guess that a lot less of you guys probably know there's actually heme bovine myoglobin inside the corn. So that there's a lot of companies, well, not a lot, but a few companies in Boston area that are actually working on that technology, which is very similar to your technology. I think the significant advantage we could take from sort of plants is in a way, in my eyes, I think it's very similar to the sort of the second generation biofuel industry, if you think about it, right? So you're culturing a whole bunch of tobacco plants, and when you harvest the tobacco and get them into the traditional industry, and when the harvest part is done, what you're left with is tons of lignocellulose. So if I could do some molecular farming with it, and then those sort of softened lignocellulose could contribute significantly to biofuel industry and can be easily broken down by cellulase. I think that's a very similar idea there. And then you can take advantage of existing planting and existing agricultural system. You don't have, to the extent you don't even have to worry about how to get closer to the traditional agricultural supply chain, which is really another significant advantage. So we really love that idea.
Great. All right, well, thank you to all of our panelists, and I will... Oh, yes.
We actually have time for one more
we
question.
Do. Okay,
I did want to just make a quick announcement. If you just heard, it is the first Tuesday of the month at 10 a.m. So if you all just heard those sirens, that's just a test. So anyway, you alluded to this earlier, Michelle, but I wanted to know if you could, we do have a little bit more time, so if you wanted to elaborate on this. Can you talk a little bit more in depth, and this to any of you, about partnerships with alternative protein sources in non-food applications such as bioplastics or other things?
Yeah, I mean, I think biomanufacturing's impact could be so much bigger than just in the protein standpoint, and especially when we look at making alternatives for carbon-intensive processes in chemicals and oil and gas. And I think there's just like so many different ways in which you can use the same platforms that you would make an alternative protein to make other components. And so, for example, precision fermentation kind of comes back into play. Like, there are people who are working on making palm oil replacements. It's not a protein, but you're still using the same pathway of engineering a microbe to create oil that will displace mass deforestation in rainforests, which end up having a carbon impact which is the same as fossil fuels because of how much CO2 is released. Any thoughts on your end?
Yeah, I would maybe just add kind of in two major categories of, maybe for precision fermentation has been advancing. One is kind of, let's say, chemical alternative, right? Alternative solutions in chemical industry, and the other one is in agriculture. And I think basically the whole concept of alternative protein sits in agriculture. And we don't really kind of kind of advocate or talk much on the chemical alternative is just because that part has already been sort of in a way significantly advanced, right? If you look at companies like Novozymes and DuPont, we don't really ask them how exactly you produce these enzymes, but the majority of their enzymes oftentimes actually come from fermentation. So for example, the enzymes that's in your detergent, for example, the enzymes that you use for cellulase that break down lignocellulose to convert them into sugar, that's all fermentation products. It's just we don't really, let's say, like significantly advocate them because they are very mature processes. For example, cellulase basically can get you somewhere around 180 gram per liter protein titer in a 72-hour fermentation. And relatively speaking, none of the alternative protein fermentation technologies can basically get to that kind of KPI. So that's why we need to advocate for the agricultural side of the contribution that precision fermentation is bringing in. And in that category then, I mean, there's, if you kind of break them down into a few sort of subcategories, there's the alternative protein, which in alternative milk and meat and other things. And then the second major category is flavors and fragrances is basically. That could be also for, you know, food use and cosmetic use and other chemical uses as well. And then the third one is basically renewable chemicals. And again, we don't really hear much in that third category is because things are already at a very significant scale. For example, you know, Cargill and ADM, you guys know how much ethanol they produce for industry use. So yeah, I think these are the two general categories where precision fermentation could keep contributing to.
And on the insect side, a lot of people refer to us as an insect protein company, but I mentioned earlier that we really have like 3 main ingredient families: our proteins, our oils, and that frass we talked about. And our oil has a very similar fatty acid profile to other premium vegetal oils like coconut oil or palm kernel oil, high in lauric acid, a medium chain triglyceride. And so we're really exploring a lot of those different avenues. I kind of alluded to this earlier, the cosmetic industry, biofuels, things like that. Again, where these nutritional profiles work well is where we're going to explore. It doesn't necessarily necessitate it being in a food or feed application.
I think the question was also about partnerships, and I think like a really good example is LanzaTech. Super integrated with this topic of discussion, but LanzaTech just IPO'd through a DSPAC a couple weeks ago, and they're based out of Illinois as well and New Zealand. And they take waste gas from like a steel company. So like carbon monoxide, carbon dioxide that would otherwise just go straight into the air. And they use precision fermentation to literally turn the carbons in that wasteful gas into ethanol. And they make sustainable aviation fuel out of it. And ethanol is a precursor to plastics and to so many different types of chemical molecules. And then they're left with biomass, which is like the microbe itself. And that microbe can be used from a protein standpoint or in a material application. So like kind of overlaying food and materials companies with steel companies and fermentation companies. There's so much opportunity for partnership with different waste streams because of precision fermentation and other types of fermentation. It's still happening in their stomach, right? And insects are fermentation too.
All right. Well, thank you very much to all of our guests.
Well, thank you.
Thank you, Jack.